July 1st, 2025, Rio Hurtado, Chile. The Atlas Survey Telescope picks up something moving fast through the constellation Sagittarius. Too fast. The object gets a temporary name, a 11PL3Z. Within hours, follow-up observations from around the world confirm what the computers already calculated. This thing is not from here. You're looking at 3I Atlas, the third interstellar object ever discovered entering our solar system. It's traveling at 58 kilometers per second. That's 200,000 miles per hour, 600 times faster than the fastest race car on Earth. And unlike every comet we've ever seen, it started glowing when it was still 4.5 times farther from the Sun than Earth. Most astronomers called it a comet. Harvard's Avi Loeb called it something else entirely. If you value documented astronomical research like this, subscribe. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from Avi Loeb's peer-reviewed papers published in August 2025, in collaboration with Adam Hibbard and Adam Krall from the Initiative for Interstellar Studies, and data from NASA's Hubble Space Telescope observations, published by David Jewett and colleagues in the Astrophysical Journal on August 7th, 2025. Now back to the information. The numbers don't lie. 3I Atlas has an orbital eccentricity of 6.141. That's the highest ever recorded for any object passing through our solar system. For context, 1.0 means a perfect circle around the Sun. Anything above 1.0 means the object is moving too fast to ever return. 3I Atlas makes even Oumuamua look slow. But speed alone doesn't make an alien probe. What caught Loeb's attention was the trajectory. The object is moving in retrograde motion, backwards compared to everything else in our solar system. Its orbital plane aligns within 5 degrees of Earth's orbit. Well, the odds of that happening by chance, 0.2%. It gets worse. 3I Atlas will pass unusually close to Venus, Mars, and Jupiter this fall. The probability of that alignment, if the arrival time were random, 0.005%, June 14th, 2025. Before anyone knew 3I Atlas existed, NASA's TESS satellite was already tracking it. The images, discovered only after the official announcement, show something unprecedented. The object was active, glowing and outgassing when it was 6.4 astronomical units from the Sun. Most comets don't start showing activity until they're inside 5 AU. This thing was already working before it should have been July 21st, 2025. The Hubble Space Telescope captures the most detailed image ever taken of an interstellar object. What it shows breaks the rules. Instead of a tail streaming behind like every other comet, 3I Atlas has an anti-tail, a glow extending toward the Sun, not away from it. David Jewett from UCLA, who led the Hubble observations, tells reporters it's like glimpsing a rifle bullet for 1,000th of a second. The Hubble data reveals a teardrop-shaped cocoon of dust coming off the nucleus. The object appears to be ejecting 6 kilograms of small dust particles per second and 60 kilograms of large dust particles per second. But here's what doesn't add up. No spectral features of cometary gas are found in the observations. Water vapor, barely detectable. This is supposed to be a comet. August 6th, 2025. The James Webb Space Telescope turns its infrared eye toward 3I Atlas. What it finds rewrites the book on interstellar chemistry. The object has one of the highest carbon dioxide to water ratios ever recorded in a comet, 8:1. Normal comets show the opposite pattern. Webb detects carbon dioxide, water ice, carbon monoxide, and carbonyl sulfide in the coma. But the CO2 dominance is unprecedented. Charles Leese from Johns Hopkins, analyzing the SphereX data, reports a carbon dioxide cloud extending at least 348,000 kilometers around the object. That's nearly the distance from Earth to the Moon, yet no comparable water cloud exists. The CO2 mass loss rate is 70 kilograms per second. The water? Less than 4.5 kilograms per second upper limit. Loeb proposes a rating system he calls the Loeb scale. 0 means definitely natural. 10 means confirmed alien technology. He gives 3I Atlas a 6, 60% chance of artificial origin. When pressed by reporters, he explains his reasoning. The retrograde trajectory is fine-tuned. The arrival time is too convenient. The size is unprecedented for an interstellar visitor, and the glow isn't behaving like sunlight reflected off cometary dust. August 21st, 2025. The Very Large Telescope in Chile detects cyanide and nickel in 3I Atlas's coma. This is the first detection of metal in an interstellar object's atmosphere. The presence of nickel suggests the object contains metallic components that shouldn't exist in a pristine comet from another star system. Loeb isn't alone in his speculation. Adam Hibbard and Adam Crowell, researchers at the Initiative for Interstellar Studies, co-author papers exploring the spacecraft hypothesis. They calculate that if 3I Atlas is artificial, its timing allows for optimal reconnaissance of our solar system. The object will be hidden behind the Sun during its closest approach on October 29th, 2025. Perfect for avoiding detailed Earth-based observations during peak brightness, September 10th, 2025. 2 months after discovery, new images from the Gemini South Telescope show 3I Atlas developing a proper comet tail 30 arc-seconds long. Finally, something normal. But Loeb remains unconvinced. He notes the tail appeared only after months of observations that showed no conventional cometary features. Critics push back hard. Jason Wright from Penn State University calls Loeb's claims nonsense on stilts. Chris Lintott from Oxford says any suggestion that it's artificial is an insult to the exciting work being done to understand this object. The astronomical community largely treats Loeb as an outlier chasing headlines, but Loeb has data on his side. The object's brightness decreases more sharply with distance than expected for reflected sunlight. The lack of water vapor at distances where it should be abundant, the precise alignment with planetary orbits, the unprecedented size for an interstellar visitor. Each anomaly alone might have a natural explanation. Together, they form a pattern. October 3rd, 2025. 3. I Atlas passes within 29 million kilometers of Mars. The high-rise camera aboard the Mars Reconnaissance Orbiter images the object with 30-kilometer resolution. Loeb calculates that if 3I Atlas has a precursor probe traveling ahead of it, the probe could intercept Mars during this flyby. Ground-based telescopes can't detect objects smaller than 100 meters, exactly the size limit of human space probes. The minimum orbit intersection distance between 3I Atlas and Mars is only 2.7 million kilometers. For an object supposedly on a random interstellar trajectory, this represents remarkable fine-tuning. Loeb suggests that an orbit correction of just 10 to 15 kilometers per second during September could shrink the closest approach distance to zero. October 29th, 2025, perihelion. 3. I Atlas reaches its closest point to the Sun at 1.36 astronomical units. It's traveling at 68 kilometers per second, its maximum speed. From Earth's perspective, the object is hidden behind the Sun. Perfect timing for what Loeb calls a clandestine reverse solar Oberth maneuver. If 3I Atlas is a spacecraft, this is when it could use the Sun's gravity to brake and remain bound to our solar system. The Hubble Space Telescope will perform ultraviolet spectroscopy on 3I Atlas in November 2025 to determine the composition of its gas emissions. Webb is scheduled to observe again in December 2025 after perihelion. If the object shows signs of maneuvering or deploys smaller probes toward Earth, we'll know within months. Loeb proposes using the Juno spacecraft, currently orbiting Jupiter, to probe 3I Atlas when it passes within 53.6 million kilometers on March 16th, 2026. 2 impulses of thrust could bring Juno within 25 million kilometers of the object's path, using only 60 kilograms of propellant. NASA has not responded to the proposal. The stakes couldn't be higher. If 3I Atlas is natural, it's still the oldest comet ever observed, possibly 7.6 to 14 billion years old based on its galactic trajectory. If it's artificial, it represents first contact with an extraterrestrial intelligence. Loeb warns that ignoring the technological possibility before analyzing the evidence is not a mark of intelligence on our end. 3I Atlas will make its closest approach to Earth on December 19th, 2025, passing within 167 million miles. It poses no threat, but if Loeb is right, if this is reconnaissance technology from another civilization, then everything changes. The object's trajectory suggests it originated from the Milky Way's thick disk, where 10 billion-year-old stars with heavy element compositions different from our Sun reside. December 2025. 3I Atlas moves through the constellations Virgo and Leo, growing dimmer as it heads back toward interstellar space. Earth-based telescopes lose track of it by early 2026. If we're going to learn its true nature, it has to be now. Every observation counts, every spectrum matters. Because once 3I Atlas disappears into the void between stars, we may never see its kind again. The Vera Rubin Observatory comes online this year, projected to find 1 to 2 new interstellar objects annually. Dozens more visitors like 3I Atlas await discovery, each one a potential message in a bottle from distant civilizations, each one a test of our scientific courage. Will we dismiss them as rocks, or will we look closer? What makes 3I Atlas particularly unsettling is its chemical signature. Regular comets from our solar system show predictable compositions. Water ice dominates. Carbon dioxide appears in smaller amounts. Methane and carbon monoxide sublimate first as objects approach their parent star. 3I Atlas flips this script entirely. The Sphere-X observations from August 8th through 12th, 2025, revealed something unprecedented. At 3.2 astronomical units from the Sun, 3I Atlas was losing 70 kilograms of carbon dioxide per second. Water vapor, less than 4.5 kilograms per second upper limit. Most comets at that distance would be streaming water vapor. This object was barely producing any. Charles Liss from Johns Hopkins Applied Physics Laboratory, lead author of the Sphere-X findings, noted that the lack of a bright water gas coma was puzzling, since 3I Atlas was not too far outside the solar system's water ice line at 2.5 AU during observations. The object should have been releasing substantial water vapor. Instead, it remained stubbornly dry. The carbon dioxide cloud extends outward for at least 348,000 kilometers. That's roughly 90% of the distance from Earth to the Moon. Yet, Sphere-X detected 3I Atlas as a point source. No extended dust coma was resolved. This suggests the glow seen in Hubble images comes from a compact source, not from scattered sunlight on a typical cometary dust cloud. Loeb seized on this discrepancy. In his August 25th Medium post, he calculated that the CO2 mass loss amounts to ablating just a millimeter thick layer from the surface of a 46-kilometer object over 10 years. This means a relatively thin outer coating could maintain the observed gas and dust cloud around 3I Atlas. What lies beneath that coating remains unknown. The timing of 3I Atlas's discovery adds another layer of intrigue. Sam Dean, an amateur astronomer who contributed to the pre-discovery observations, suspected the object wasn't found earlier because it was passing in front of the Galactic Center's dense star fields during May and June 2025. The comet would have been nearly impossible to distinguish against that crowded stellar background. This raises questions about how many other interstellar visitors we've missed. Objects approaching from the direction of the Milky Way's central bulge would remain hidden until they cleared those dense star fields. 3I Atlas may represent not an anomaly, but the first in a regular stream of visitors we've been blind to detect. Miguel Alarcón and researchers at the Instituto de Astrofísica de Canarias, using the Teide Observatory's 2-meter twin telescope, confirmed cometary activity on July 2nd, 2025. Multiple telescopes showed the object's coma had a reddish color indicative of dust, similar to 2I Borisov, but there the similarities ended. Tony Santana-Rose and colleagues published findings in August 2025 showing 3I Atlas's coma had become progressively redder throughout July, indicating an evolving surface or coma composition. This color change suggests the object was reacting to solar heating in unexpected ways. Normal comets don't show this type of spectral evolution over such short timescales. The polarimetric observations conducted by the Very Large Telescope, Nordic Optical Telescope, and Rosen Observatory from July through August 2025 revealed that 3I Atlas's coma exhibits unusually high negative polarization at small phase angles. This means a large percentage of reflected light has oscillations oriented along the Sun-Comet observer plane. Such polarization signatures are typically seen in trans-Neptunian objects, not in active comets. This polarization pattern suggests 3I Atlas's coma consists of a mixture of icy and dark material. But the specific combination required to produce these observations doesn't match known cometary compositions. The object appears to be made of materials we don't fully understand, arranged in ways that defy conventional comet physics. The dust dynamics around 3I Atlas tell another strange story. Based on Hubble observations from July 2025, small dust grains with 1 micrometer radii get ejected from the nucleus at 22 meters per second. Large dust grains with 100 micrometer radii move at only 2 meters per second. This size-dependent velocity distribution indicates the object's gravity and surface properties don't behave like a typical comet nucleus. Alan Hale, the discoverer of Comet Hale-Bopp, initially reported no cometary features in early observations of 3I Atlas. Only later observations on July 2nd by multiple professional observatories revealed the marginal coma and potential tail-like elongation. This delayed appearance of cometary activity is highly unusual for objects at 3I Atlas's distance from the Sun. The pre-discovery observations extend much further back than initially realized. The Zwicky Transient Facility captured images from May 22nd through June 21st, 2025. The Weizmann Astrophysical Observatory found even earlier observations from May 21st. These archives show 3I Atlas was already bright and active when it was roughly 6.4 AU from the Sun in May. No comet should be active at that distance. Water ice requires temperatures of hundreds of Kelvin to sublimate. Objects need to be much closer than Jupiter's orbit to begin significant water ice loss. Carbon dioxide ice requires temperatures around 100 Kelvin, achievable at distances comparable to Saturn's orbit. But 3I Atlas was showing activity beyond Saturn's distance, in the cold outer reaches where only the most volatile ices should be escaping. Loeb's team calculated that 3I Atlas likely entered the outer boundaries of our solar system around 8,000 years ago. This timing coincides remarkably with the development of advanced human technologies and the beginning of recorded history. Sumerian cuneiform writing appears around 3200 BCE. Egyptian hieroglyphs emerge around 3100 BCE. The first documented astronomical observations begin around the same period. If 3I Atlas is a reconnaissance probe, its arrival time suggests whoever sent it knew when to expect technological development on Earth. This implies long-term monitoring of our planet spanning millennia. The alternative explanation, pure coincidence, requires accepting odds so astronomical they strain credibility. The retrograde trajectory analysis reveals additional fine-tuning. 3I Atlas approaches the Sun from the opposite direction compared to planetary motion. Its orbital inclination of 175 degrees means it's moving backwards through the solar system, yet its path lies almost perfectly within the ecliptic plane where planets orbit. Random interstellar objects should arrive from any direction with equal probability. The chance of such precise alignment is 1 in 500. Jacqueline McClary, assistant professor of physics at Northeastern University, noted that for 3I Atlas to have started glowing as far out from the Sun as it did was abnormal enough to result in early theorizing that it must be an alien spacecraft. The object was producing light at distances where no natural mechanism should be active. What else that small and fast would be generating illumination? The European Space Agency confirmed they have multiple spacecraft positioned to observe 3I Atlas during its Mars flyby, the Mars Reconnaissance Orbiter, Mars Express, and ExoMars Trace Gas Orbiter will all attempt imaging during the October approach. If precursor probes exist, as Loeb suggests, Mars-based observations offer the best chance of detection. Loeb's proposal to use Juno for close-range reconnaissance has gained support from unexpected quarters. Adam Hibbard from the Initiative for Interstellar Studies calculated that 2 thrust impulses totaling 60 kilograms of propellant could position Juno within 25 million kilometers of 3I Atlas's trajectory. This represents only 3% of Juno's initial fuel allocation. The window for such a maneuver closes rapidly. Juno would need to begin course corrections by late September 2025 to intercept 3I Atlas during its march. 2026, Jupiter flyby. NASA's silence on the proposal speaks volumes about institutional reluctance to seriously investigate the artificial hypothesis. November 2025. Final observations reveal 3I Atlas has completed its journey around the Sun without fragmenting. Without the dramatic outgassing expected from a comet making its first stellar encounter, its nucleus remains intact, its glow persists. And somewhere in Harvard's astronomy department, Avi Loeb updates his calculations one more time. The most recent observations, published September 10th, 2025 by ESA show 3I Atlas maintaining structural integrity even as its anti-tail phenomenon continues to defy conventional comet physics. Unlike 2I Borisov, which behaved exactly like comets from our solar system, 3I Atlas keeps breaking the rules. The International Astronomical Union has remained conspicuously silent on Loeb's artificial hypothesis. No official statements address the anomalous properties. No working groups investigate alternative explanations. The silence suggests either complete dismissal or careful consideration of implications too profound to discuss publicly. Richard Moisel, head of planetary defense at the European Space Agency, told reporters there have been no signs pointing to non-natural origins in available observations. But Moisel's statement predated the most anomalous findings. The anti-tail discovery, the unprecedented CO2 ratios, the precise trajectory alignments. As data accumulated, the natural explanation became increasingly strained. In the end, 3I Atlas forces a choice. Accept that we've found the most anomalous natural object ever discovered, or consider that we've detected the first artificial visitor from another star. Loeb argues that the consequences of being wrong about alien technology are far greater than the consequences of being wrong about a comet. The object entered our solar system approximately 8,000 years ago, roughly when human civilizations began documenting history. Now it's leaving, carrying its secrets back to interstellar space. Whether rock or reconnaissance probe, 3. I, Atlas, represents a cosmic coincidence of staggering proportions. We discovered it. We studied it. We may never know what it really was, but buried in the observational data from 2025 lies a truth. 3. I, Atlas, appeared in our cosmic neighborhood with properties no natural object should possess. It moved with precision no random trajectory should allow. And it glowed with energy no conventional comet could sustain. The numbers are there. The patterns are clear. The question isn't whether 3i Atlas is anomalous. The question is whether we're ready to face what that means. 6 decades after Sputnik first taught us that space contains artificial objects alongside natural ones, we still assume every interstellar visitor must be a rock. 3. I, Atlas, challenges that assumption. And in the vast darkness between stars, something may be listening to see how we respond.